Hey guys, in this video I'm going to be going over how to do the VB sketches for CL5 and XEF4. So with each of these you're going to want to do your Lewis dot structure first. So when we do our chlorine pentafluoride, it's going to look something like this. Here we have our 5 fluorine molecules, or atoms rather, around our chlorine center. And we have an extra lone pair of electrons around our chlorine. Okay, and if we're to look at this central atom, we see that we've got 6 structures around this. We have 6 electron domains around this. So this is going to be sp3d2 that accounts for all of the orbitals that are surrounding our CLF5. So each of our orbitals are going to be making bonds with the fluorines or holding those electron pairs. So when we do our VB sketch, we'll have our chlorine in the center. We're going to have our our orbitals around here. Each of these are our sp3d2 orbitals, and then we'll have our fluorines around that, like so, where we're putting electrons in these orbitals. Fluorine itself only has 4 orbitals around it. Because it only has 4 electron domains around it. So it will look something like this. Make sure when you do your VB sketches that you have electron pairs, either lone pairs, which are shown in their orbitals without any overlap, or between the 2 orbitals like we show with our fluorine and chlorine bonds. So this would be a VB sketch for chlorine pentafluoride. Other things you'll want to do, you do need to determine the hybridization of the central atom, which we did already. We need to figure out our number of sigma and pi bonds. In this case, we have each of these direct overlaps are sigma bonds. So there are 5 total sigma bonds. We do not have any pi bonds, so our pi bonds would be equal to 0. And then if we looked at a chlorine-fluorine bond, this is a polar bond. So a chlorine-fluorine bond is polar. And because we have a asymmetric geometry, we have a polar molecule. So polar bonds and polar molecule. Okay. Next, let's look at xenon tetrafluoride. Again, the first place we want to start is with our Lewis structure. So we have 6 electron domains around this as well. We have 2 lone pairs on our xenon, and then 4 bonds to our fluorines. We have 6 electron domains, so our hybridization here is going to be sp3d2 again, to account for all 5 of those electron-containing orbitals. And then when we draw it, we're going to draw our above and below our plane will be our lone pair electrons. So it's going to adopt the same shape as we see in VSEPR, right? This is going to be a square planar structure. And then we're going to have our fluorines that will look nearly identical to the ones we just saw before. So they're going to be tetrahedral arrangement of electron domains. And these are technically going to have two sides, right? So it's going to look, when we draw them, they're supposed to look something like this, but you can ignore that small little dot. It's not important. There's not enough electron density in there to make it worth it. You can just write in the larger lobe of the orbital of the hybridized orbital. And then again, we'll go through, we'll look, it has, every time we have direct overlap, we have a sigma bond, so there are 4 sigma bonds. And then there are 0 pi bonds because we do not have any indirect overlap. And then a xenon fluorine bond is polar, so it contains polar bonds. But this is a symmetric geometry. Our square planar is a symmetric geometry. All of our bond dipoles are going to cancel out. The one here will cancel out with the one here, and the one here will cancel out with the one here. So this is a non-polar molecule. Okay, and that's it. If you guys have any other questions, please let me know, and I'll make additional videos to go over this material. Thanks, guys.